Well, hello, we're back for our final video of this series of 5 videos on problem solving and applications of linear relations. In this video we'll be looking at applying our 6 steps to solving application problems to some percentage applications. Once again we're going to see a linear type relationship here. So once again let's just review our 6 steps. First of all, read the problem just to get a general understanding. Step 2, organize the information by writing down the known and unknown values, and if needed, draw a picture or graph and label its parts. Step 3, write a formula, equation, or inequality or system of equations relating the unknown and known values. Once you get to this point, you're in pretty good shape, because then I don't think you're going to have any trouble solving the equation or system, writing down the answer, and checking. So the key is to get step 2 right, because if you get that right, you'll probably get step 3. Once you get step 3 right, you're in pretty good shape. So what we're going to look at now is percentage and proportion applications. So many applications make use of percentages or percents. In these problems, the percentage acts as the slope. So the basic relationship is then that the percent of the part of whatever thing you're interested in multiplied by the total original amount equals the amount of the part of interest. Okay? So notice that the x value is always the total original amount, and percentages are always a comparison to some original value. So many applications follow this pattern. So the basic setup is percentage of the part times the total original amount is the amount of the part. And that part could be anything that we're interested in. So for example, this can be applied in very many ways. That what I just said probably sounds a little vague, but it's because it can be so generally applied. So for example, percentage of discount times the original price gives us the amount of discount. Or percentage of sales tax times the original selling price is the amount of the tax, which of course you have to pay in addition to the selling price. The percentage of some chemical that's in a total amount of solution, multiply the percentage of the chemical by the total amount of solution, and it gives you the amount of the chemical within that total solution. A percentage of increase times the original amount gives you the amount of increase. A percentage of decrease times the original amount gives you the amount of decrease, and etc. There are many, many more examples like this that follow this basic scenario. Now, even simple interest problems basically follow this, except that the percentage of the interest is not given really as a percent. It's given as a percent per time, so you have to multiply that by time to get the actual percentage of interest. So the interest rate, which is percent per time, and of course you make it into a decimal, all these you'll make the percentages into decimals. So you take the interest rate times the time, that together makes the percentage of interest. And then times the principal, which is the another name for the original amount invested, and that gives you the amount of interest. So if you look at it, it's really the same thing, except that percentage of the part is broken down as the product of the interest rate per time times the time. So the interest rate there is not just a percentage, it's a percentage per time. And a lot of times you'll see that formula rewritten as PRT equals I, principal times rate times time equals the interest. I've got it written as RTP equals I. Now sometimes instead of seeing it written as a percentage, you might see it written as a fraction or a proportion. Same idea. Basically you have a fraction of the part times the total original amount gives you the amount of the part. So you might see it written that way. The charts here are going to be very similar to the ones we saw in the last video. So you'll have your first column for your names of your categories. Your second column will be what's going to serve as the slope, which in this case is the percentage or proportion or fraction. The next column is going to be the total original amount, and then the last, you multiply those two columns together to get the last column, which is the amount of the part that we're interested in. So the fraction, percentage, or proportion is the relative rate of increase or decrease, and it will serve the role as a slope in these basic applications. So let's look at a couple of simple applications and see if we can apply our problem-solving technique to these examples. So here's one. The sales tax rate is 8.875%. What's the amount of tax on an item that sells for $345? Figure this out and come back when you're finished. Press pause now. Well, in step 2, if we let t equal the amount of the tax, then actually I've got t and x. I shouldn't use both, either t or x. How about t? So I need to change these x's to t's. Oh, why not? I'll just do it right now. These should be t's. Okay, here we are. Now it's fixed. So the percentage of the part, the percentage of the tax, is 8.875%. But notice we always change the percent to a decimal or a fraction, usually a decimal. So this will be 0.08875. We multiply this by the amount of the tax, which is $345, and we get the amount. That's the amount of that it sells for pre-tax, and that multiply those together gives us the amount of the tax, which is just a multiplication problem. So that's 30.61, etc. So $30.62 in tax. Of course, it's money, so we're going to round off to the nearest penny. Okay. Notice that unlike most of the time where we have slopes, even though it's kind of the same role as the slope, the percentage does not have, or fraction doesn't have units on this one. A dress is on sale for $45. It normally sells for $57. What is the discount rate? Well, here's one where we're solving for the rate. So let R be the relative or percentage rate of the discount. $45 is the sale price, $57 is the original price. Let D be the amount of the discount. So the amount of the discount is 57 minus 45, which is $12. So it's $12 off. So that's the actual amount of the discount. What percentage is that? Well, when you multiply the rate times the original amount of $57, you'll get the amount of the discount, which is $12. So the rate is the percentage of the discount times the original amount gives you the amount of the discount. Solve that for R by dividing by 57. So we have 12 divided by 57, or 4/19. R decimal 0.2105, etc. So about 21.05%. So the rate of the discount is 21.05%. And of course, if you multiply that percentage times the original amount of $57, you'll get a $12 discount. And sure enough, 57 minus 45 is $12. Or if you'd rather say 45 plus 12 is 57. Alright, here's an example of what's sometimes called a solution problem or wet mixture problem. So we have Billy mixes 2 gallons of pure antifreeze with 3 gallons of 20% antifreeze. What percentage antifreeze is in the mixture? So if you notice, we've gotten some pretty good practical problems here to solve in the last few examples. So see if we can work this one out. Go ahead and try it. Press pause now. Okay, well, again, you have the percentage of the part times the total amount is the amount of the part. And the part we're interested in is what's antifreeze. So the percentage of antifreeze times the total amount equals the amount of the antifreeze. So the first part, we have 2 parts, the pure part, the 20% part, and then the total mixture, which we can solve for the percentage there. So notice the pure part is 100% antifreeze, or just 1. The 20% is 20% antifreeze, or in decimal form 0.2, and we don't know what the mixture is, x. Now since it's averaging out somehow the 1 and the 0.2, it's going to be somewhere between 0.2 and 1. But depending on, if they were equal amounts, it will be exactly halfway between these. It would be at, well, let's see, just average them, 0.6. But if we have a little bit more of the pure, it'll be closer to 1 than 0.6. And if we have more of the 20%, it'll be closer to 0.2 than halfway. So it'll be closer to 0.2 than it is to 1. So it'll be under 0.6. In fact, we do have more of the 20%, so we should expect the answer to be closer to 20% than it is to 100%. Okay, but somewhere in the middle there. So the total amount of volume of the solution is we have 2 gallons of pure antifreeze, 3 gallons of the 20%, so that is a total of 5 gallons. So notice that total amounts add up, and the amounts of antifreeze add up as well, but the percentages don't add up, they average out. So again, it's very much like the slopes that we saw earlier in things like unit value, where the percentages just like the unit values do not add up, they average out. But we have the percentage of the part times the total amount gives you the amount of the part. So if it's 100% antifreeze and we have 2 gallons, then we have 2 gallons of antifreeze. If we have but 20% of the 3 gallons is antifreeze, so that's only 0.6 gallons of antifreeze, the rest being something else that we don't care what it is, most likely just water. Okay? And so then we have this worked out. Then the volume of antifreeze is 2 plus 0.6, and we know that the total amount of antifreeze is also x times 5. So that gives us our equation. 2 plus 0.6 equals 5 times x. So 2.6 equals 5x divided by 5, and x equals 0.52, which in percent form is 52%. So the mixture that we come up with will be 52% antifreeze. Closer to 20% than it is to 100% because we have more 20%. So that makes sense. And if we do 0.52 times 5 gallons, we end up with 2.6 gallons of antifreeze, and sure enough, 2 plus 0.06 is 2.6, so that checks out. Alright, here's an investment problem. This is a simple interest kind of problem. Heather is investing $5,000 in 2 ways. Part is in a certificate of deposit that pays 4.5% interest, and the rest is invested in a stock. Of course, you don't know with stocks, they might go up or down, but this time it turned out to pay out a little bit better at 6.7%. Wish we could get a CD for 4.5% right now. That would be nice, but let's suppose this happened at some point. Her annual return on her investments is $260. How much did she invest each way? Go ahead and try this one now. Press pause. Well, we're going to have the interest rate, which is, it's a percent per year, but you're going to quickly make it a decimal. So the units are really just per year. We have the time in years, and then we'll multiply those together times the principal, the amount invested, and that will give us the amount of interest. So we have 2 investments, the CD and the stock, and then we have sort of a total combined estimate. So our formula is R times T times P equals I. So the R, or rate for the CD, is 4.5%, which we write as 0.045, and the 6.7% interest for the stock, it will be written as 0.067. Now they're both her annual return, so she's investing for 1 year. So the time is the same, both 1 year. And notice that the times don't add up either. If we leave it in the stock for a year and the CD for a year, that's the same year. They're at the same time. So our total investment is still there for a year. It's not, say 2 years or something. The interest rate we're going to get combined is going to be some sort of average between the two. It's going to be somewhere between 4.5% and 6.7%, but it won't necessarily be exactly right in the middle because we may not. It would be if we invested exactly the same amount in each kind, but if we invest more in stocks, our combined interest rate, effective interest rate, would be closer to the stock rate than it would be for the CD rate. Okay, so let's see what else we've got here. So we know there's 5,000 total. So we could do this with one variable by choosing X for either the stocks or the CD amount of principal. So X is the amount invested in the CD. So then 5,000 minus X has to be the amount invested in the stock. And so notice those do add up to the 5,000 total. Her interest then is 0.045 per year times 1 year times X dollars is 0.045X dollars of interest. That's for the CD. Similarly, for the stock, her interest is 0.067 per year times 1 year times 5,000 minus X dollars. So that's 0.067 times, open parentheses, 5,000 minus X, close parentheses, and that represents the interest that she made on stocks. Now we know that our total interest is given in the problem to be $260 in the bottom, so we've got that. And so principals add up, that's dollars. Interest adds up, dollars add up. But time and rates do not add up at all. Okay, so step 3, we get we add up in the last column there to get the bottom entry in the last column. That's going to give us our equation. So the amount of interest in the CD plus the amount of interest from the stock, that's going to be the total interest that she made for the year. So that's 0.045x plus 0.067 times 5,000 minus x, and that's going to equal $260. So distribute the 0.067, combine like terms, subtract 335 from both sides, and divide by negative 0.022, and you get x equals $3,409 and 0.09 repeating. 5,000 minus that is 1,590.90 repeating. So we're going to round off to the nearest penny because it's money here. And so we're going to say Heather invested $3,409.09 in this certificate of deposit, and then 5,000 minus that, that's $1,590.91 in the stock market. Let's check it out. If the money in the CD is left in for 1 year at 0.045 or 4.5% per year, that's going to give you 0.045 per year times 1 year times $3,409.09. So to the nearest penny, that's $153.41 of interest. And the stock, it's not really interest in the stock, but it's increase in value. So the increase in value is 0.067 per year times 1 year times $1,590.90, and that's an increase of value of $106.59. So the total amount of return in terms of her increase in value is $260 when you add the two together, and that's what it's supposed to be, so it checks. So after studying this series of lectures on problem solving and applications of linear relations, what should you be able to do? Well, first of all, you should be able to apply multiple problem solving strategies, particularly the, 6 steps of solving applications. And we should solve applications using these 6 steps that involve linear equations, or even though we didn't do any examples of this, you should probably be able to generalize this to linear inequalities or linear functions, including but not limited to some number puzzles, some velocity applications, unit value, and some percentage applications. Now remember, we're going to be able to use these same steps in other situations throughout the rest of the course as we go forward.